Hello everybody and welcome back to 3D Printing 101. Today we're going to be going over how to perfect the first layer. The first layer is pretty much the most important layer in the entire printing process. I know that if I get my first layer correct, if I get it to print perfectly, nothing's perfect obviously, but if I get it to print really well, then most likely the rest of my print is going to go well also, as long as I've checked everything in my slicer beforehand. Here's why it's so important. Your first layer is the foundation that everything else sits on top of. So if your first layer is not adhering right, then your print could just fall off, or it could warp, which we'll talk about later. If your first layer it's not even, then your print is not going to be even and the dimensions are not going to be accurate. There's so much more we're going to talk about. Welcome. First things first. Start watching your prints. This is especially true for beginners, but even now, I still watch the first layer whenever I can. I like to go back through and check on my prints, especially if they're long prints, every once in a while. But the first layer is the one that I prioritize the most. Like we said, it's the foundation for everything. Everything. So if the first layer is a little bit messed up, then the whole print is pretty much going to be messed up. It's also a clear indicator of some other important things that you might not have noticed earlier when you're preparing the print. A bad first layer could indicate nozzle problems, it could indicate temperature issues in the slicer, issues with your filament, or just is your printer calibrated and is it level? These are all things that we're going to go over. So we hear a lot of talk about adhesion and how to get your prints to stick to the build plate. But it's really a balance because you want it to stick to the build plate until you're done printing. And then you want it to be able to come off without ripping apart the build plate. I have old build plates that, I've made the mistake of, printing it too close or printing it at the wrong temperature or with the wrong material in the wrong way. And it ripped off parts of the build plate. If you have a cheap build plate, this is probably going to happen at some point, no matter what. But there are things you can do to make sure that doesn't happen to you soon, right? So it's always a balance. As with most other things in life, people who are very strongly on one side or the other, the extremists are sometimes right, but very, very rarely. Usually it's the people who can see the value in both sides, but also sort of the delusion, and just make a good answer. So you don't want it to just totally stick to it. Otherwise, we would just use super glue, and it would work fine. But also, if it's too loose, if you make it too easy to come off, it's gonna come off while you're printing, even if it's a small print. So step one, if you're having troubles with the first layer, or you really want to perfect it, is make sure the bed is level. Little side note, I used to never level my bed at all. When I first got my printer, I leveled it, I set it all up, but I didn't fully understand how to level it, and I was just too impatient, and I didn't want to go through the process of leveling it. And then what I do? I just figured it out. I looked through the manuals, I looked online, I looked on blogs. I was like, how do I level the print bed? And then I found it, and I spent maybe an hour figuring out just how to get it perfect, which if you're following this course, I hope that it does not take you an hour to figure it out, because I try to condense this down as much as possible. But once I did that, my prints 100x'd. I was having tons of issues, just off the charts. The prints were looking awful. It looked like the 3D printing equivalent of like a 7-year-old's attempt at drawing the Mona Lisa. It was a mess. But then I leveled the bed. That's all I did. I leveled the bed, and once I did it the first time, I could do it way faster the second time. Maybe it took me maybe 15 minutes of trying the first time, 15, 20 minutes, 25 minutes. Second time, 10 minutes. 5 minutes. Now I can do it in, 2 minutes. And honestly, you don't need to do it every time, But if you just make a habit of, every week, a couple times a week, making sure your printer bed is leveled, you are going to level up your prints. And because the reason that this is going to happen is because your first layer, you're noticing a theme here? Your first layer is going to be good. It's not going to be uneven. It's not going to be the wrong distance away. It's going to be a good, solid foundation on which to build whatever you want. Leveling the bed is not just about getting it even. It's not just about getting it level, as in like tilted the correct way. What's also important is getting it the correct distance away between the nozzle and the build plate. Now, I already went over bed leveling briefly back in Unit 1. So if you're not familiar with it at all and you haven't leveled your bed up to this point, I don't know how you would have not leveled your bed and gotten to this point in the course. But if for some reason you need to refresh, and that's totally okay, just go back to Unit 1 and click on Make Your First Print. And in that, you can skim through. I'll show you exactly how to level your bed for the first time. Now, it doesn't have to be hard. You can use the sticky note trick, which we talked about, where you use a sticky note to kind of gauge the tightness between the nozzle and the print bed, or you can use a calibrating 3D print. This file on Thingiverse, I'll leave the link down below, but it's going to help you calibrate your printer. You basically put it in your slicer, and then you size it up so that it's almost the full size of the build area, and then you print it out. Now, if you're having any trouble with getting this to work with your printer, if for some reason it's not printing out, then that might be because it's not the correct height for your layer height. So there are two ways you can go about attacking this. You can either go to the left side in Cura and deselect uniform scaling, and then you can just increase the Z height, the vertical, until it gets to 0.2 millimeters, or whatever layer height you're trying to print with. I would recommend 0.2. Or you can go into the layer height and you can change it from 0.2 or whatever it's set to 0.12. Now, you can try one of these, and if it doesn't work, go to the other one. And if both of those don't work, and you've done some problem solving by yourself, hop into the community tab, post it as a question, and we're gonna help you. It's that simple. If you're more comfortable, you can also just message me directly, and I'll help you out. Now, when you're actually printing this, you can make micro adjustments as you go. You can spin this wheel a little bit if you notice, it's a little too low on this side, or it's a little too high on this side, or just something doesn't look right. You can make micro tweaks because, especially on a model like this, very, very low stakes. You're not actually printing something to have the print. You're printing something to calibrate the printer. So don't worry about messing something up. Just make very, very minor tweaks, and they're going to have big differences. Remember, we're talking about 0.2 millimeters of layer height, sometimes 0.12 millimeters. That's pretty small. It's like a sheet of paper. A little thicker than it's thicker than a sheet of paper, but it's very, very thin. You can use this diagram to figure out how much you need to change something in order to get it fully dialed in. The Z offsets. The Z offsets are very, very closely tied with what we talked about before, making sure that the nozzle is the correct length away from the bed. Now, you can set your Z offset usually either in your printer or on your computer. And what that does is it just raises or lowers your print head to match where you need it to be in order to get the right print. And you can do this, again, you can perfect this by using the file that you can get from Thingiverse. Okay, once you are sure that your print bed is fully leveled and it's in the correct distance away throughout the entire bed, you're sure that that is done, because that, I'm telling you right now, that is going to be the main reason for most of you why something is not working with your first layer. That's going to be probably the main reason, at least in the beginning, it's going to be the main reason why your prints aren't turning out great, period. But once you've mastered that, we'll talk about cleaning the bed. Cleaning the bed is something that's important to do very, very often, and it doesn't have to be hard. I use Isopropyl alcohol, this is 50% isopropyl alcohol, but you can get this at the dollar store. It doesn't really matter what percentage it is. It just, depending on how much water is in here, that's what the 50% is. It's just saying half of it's alcohol, half of it's water. Depending on how much water is in here, it's going to change how fast it evaporates from the print bed, and it will evaporate faster while it's hot. In addition to that, I just use a microfiber cloth. Any type of cloth is going to work better than something like a paper towel, because a paper towel, it leaves these fibers, if you've noticed. If you're wiping something down with a paper towel, it just leaves these microfibers, and that could, sort of leave debris on your build plate, and it could impact the adhesion. So pick yourself up a microfiber cloth. You can get them at Harbor Freight, Amazon. I'll leave some links down in the description. And alcohol. That's all you need to clean your build plate. There are a bunch of different ways you can use that, even if your build plate is super duper filthy, and we'll talk about that in a later lesson. But using those two things, making sure your build plate is clean. If I have a really big print or something, I definitely make sure that I clean this before and after, because it's a very small time investment to make to just level and clean your print bed, but it can save you a bunch of time in trying to reprint, wasting filament, fixing your printer, if you just do those things early. Okay, next up, something that a lot of people don't realize is you can actually use things like a glue stick or painter's tape to increase your bed adhesion. Bed adhesion just refers to how well does it stick to the printer. So using something like painter's tape is going to slightly raise up the build plate, and a lot of times it can make just the texture of this is easier for the filament to stick to while it's printing. You can also use a glue stick. So it says it right on here, washable school glue stick, disappearing purple. So the great thing about this, these are washable. You can get them for dollars, and then once you put it onto your print bed, if you're like, oh man, my print bed is so sticky now, I can't do anything with it because it's so dirty, just put it under the sink, let it soak for a little while, and you might have to use some alcohol again, but the glue stick, it works wonders. Sometimes I'll put it on even in just small areas if I have a print that's more complex, or there's something that I've had trouble with in the past. I'll just take the glue stick out, put a little on in that spot, let it go. That's it. Don't try to use like hot glue or super glue or anything, because try those. Just learn the lesson without getting the scar. Don't try those. Something that a lot of people also use, and I've experimented with in the past, is hairspray. This is much bigger, sort of gap, because one, there's a lot of different kinds of hairspray. There are not, there's no Elmer's glue stick of hairspray. There's not. Like, if you buy a glue stick, it's going to be basically the same type of thing, and it's going to work the same. Same thing with tape. Like, they are made to serve function, and that is tape, but not too much, and be this material. But hairspray ranges a lot. So I've had some times where it was really successful, and sometimes where it really wasn't. And make sure that the hairspray that you're using doesn't ruin your printer, because if you get oils on it, those oils can sort of damage your printer and ruin your print. So if you use hairspray, you got to make sure you clean it well after. And just approach the hairspray method knowing there's a good chance it's not going to work. Although it could, and you never know. When you're using materials like TPE and PETG, they tend to stick to the build plate much more strongly. So in that case, you might want to use some type of release mechanism. Different types of, sprays and stuff that you can get to put on them. But that is a bit more complex, and most likely you're not going to have to start with that. I wouldn't really approach that until you've tried all these other things, because these other things, I would say, affect way more prints, can be fixed much faster, and for a lot of them, you don't need anything special to do it. All right, next up is slow down the first layer speed. You can do this in the Ultimaker Cura slicer, and we talk about this in another lesson where we go deep into how to use slicers. So if you have not watched that one, you can check it out after you watch this. But basically, you can slow down the initial speed. If you don't want to slow down the entire print, good, you don't have to. You can just slow down, you can just choose to slow down the first layer. Now, by default, usually it just takes half of what your normal speed is set to and sets that as the first layer speed. But if you want to go even lower than that, or maybe faster than that, because for some reason the filament is just on there for too long, you got to experiment a little bit, but you can manually change that just by typing it in. It's that easy. If for some reason you don't see all of those settings when you click on speed, you can go to the advanced setting in the top right corner of your options tab. Okay, temperature. Like we already talked about back in our filaments video, temperature ranges a lot. This filament I have over here goes, I'd say, between 210 and 220, but it depends on your climate and how humid it is, how warm it is in your printing environment. Tons of factors. The filament that you're using, like we talked about. So you're really going to have to toy around with this. I would start with going with what the manufacturer has printed on the filament roll. Once you've gone through the ranges, go up by 5 or 10 degrees or go down by 5 or 10 degrees. If you go down by 5 or 10 degrees, I'd say that's a good place to start, because, but if you go down too much, then you do run the risk of having, filament clogging issues or other problems, because if you try to take a piece of plastic, and squeeze it down through a tiny little nozzle, and it's cold, it's just going to keep pushing it and pushing it and pushing it, and something has to break at some point, right? But on the other hand, if you have it too hot, it could go past the point of melting, and things could not get good. Things could get bad. Okay, enclosures. You might be thinking, enclosures, aren't those super expensive? Yes and no. Yes and no. They can be expensive if you buy an expensive one. But sometimes when I'm running a print and, let's say there's a lot of stuff going on around it, I will just put up some pieces of cardboard just around it, or, sometimes people even use a garbage bag, and I've seen it work really well because it keeps dust and wind out, so you're not having these huge fluctuations, and you're not having to worry about having dirt or debris get on your printer while it's trying to print, because number one, if that gets on the build plate, then not good, because your printer's going to be trying to print over it, and it's going to be like, oh, there's a thing here, I've got to either jump over it, I've got to bump into it and run it away. Also, if you get debris, dust, little bits of dirt or something in here, like inside of the printer itself, it's not going to be able to move as well. Your calibration is going to get thrown off, and your printer will not be able to perform if it's got stuff floating around it. Like, think if you were trying to say you're trying to build a desk. And while you're building that desk, everyone is throwing rocks at you. And in addition to that, there's a giant fan blowing really hot and then really cold air at you. It's going hot and cold and hot and cold. It's going to be much harder for you to build that desk. That's what your printer is trying to do when you have major temperature fluctuations. If there's a lot of air circulation in there, it's unstable. or if it's in a dusty environment. Like down here in my workshop, there's a lot of dust. So I have to regularly go through and clean my printers. And a lot of times, yeah, if I'm doing something or I'm cleaning, I'll just put up a shield. That's it. Doesn't have to be some fancy multi-$100 or sometimes even $1,000 printer or printer enclosure that you buy from like Matter Hackers or something. It can just be a garbage bag that you put on top of the printer. One thing to note here though is when you are experimenting with something like an enclosure or having a bag on it or something, it can lead to an abnormal increase in the temperature in the 3D printer environment. So think about it like a blanket. Right now, I don't have a blanket on and I'm not cold, but let's say, like I'm a good temperature. I am. I'm not too cold, I'm not too hot, but right now my body is producing heat. It's just not retaining that. Some of the heat is traveling out of my skin into the air around me. And that's what is happening with your 3D printer. It's heating up the bed, it's heating up the nozzle, and it's always losing a little bit of heat. But once you put an enclosure around that, it sort of stabilizes the air inside of it, and it keeps that temperature from dropping and going to other parts, from spreading. So it acts like a blanket. So when I put a blanket on, I'm not actually producing more heat. My body is just retaining more of it because it's kept inside from the blanket. So sometimes if I've got too many blankets on, if I've got like 4 wool blankets on, then yeah, I'm going to get hot. I'm going to get really sweaty. And that is the same way with your 3D printer. So make sure you check back in on it and don't just overdo it. You can definitely overdo it, especially if you're printing at higher temperatures, like if you're printing with ABS or something like that, you could run into issues there. So in addition to the nozzle temperature, the bed temperature also plays a key role because once, especially on that first layer, once the filament goes down, it needs to stick to something. And as that filament goes down, it's going to go from a very, very hot place to a much cooler place. Not necessarily cool, but cooler. You're going from 220 degrees Celsius to 70 or 80 degrees Celsius. So if you change your bed temperature, you're going to change how much that filament contracts. And that is definitely going to affect how well your first layer turns out. Another thing, in addition to the temperature of the nozzle and the temperature of the bed, which are the two things that people most often associate with the temperature controls on your 3D printer, is your fan speeds. You can either change your fan speeds in the slicer or directly on your 3D printer. But what your fan speeds do is it changes how fast and how well the filament is cooled once it comes out of the nozzle. Slicer changes. If you're still having problems and you've adjusted all of these things already, you might have to add one of 3 things: a brim, a raft, or a skirt. Now, skirts are a lot of times they're just put onto the printer as a default. Almost all of my prints print automatically with a skirt, and the skirt does less than the brim or the raft. The brim and the raft are more extreme measures, and they can, alter the quality of your final print. It's a trade-off. Having a good first layer and maybe sacrificing, how smooth some of the edges are or how the bottom is for having a good rest of the print and having it be, more controllable, I guess is the word. But when you print with something like a brim, I would go to a brim before I go to a raft. On a brim, it basically just adds a tiny 1 layer of plastic that goes all the way around the part. And this just increases the print area. That's it. It increases the size of the space where your print attaches to the build plate. Now, brims have saved me a lot of times in a lot of different cases, but not all brims are created equal. So you can experiment with, how big your brim is. But another thing you can try is, and this is a little bit more advanced, I'll show you how to do it in a later episode, but what you can do is you can make custom brims in your 3D modeling software. Rafts, I hardly ever use rafts. But when I do, it's for a big reason. Basically what a raft is it's about 1 millimeter thick of filament, and it's just a sheet that prints onto the print bed before your 3D model that you've loaded in your slicer actually starts at all. This is like a brim, but thicker. So, I'd say this applies more when you have an unlevel bed rather than any of the other issues. A brim is going to leave some effects on your print, but it's mostly going to be on the edges when you try to clean up the removal of that brim. A raft, on the other hand, is going to leave much more severe effects on the bottom of your print. There's going to be a much less clean underside. If you have a print bed, a lot of times the texture of that print bed is going to translate onto the final print. So I have this coarse surface, and if you flip it over, I also have this smooth surface, depending on what kind of prints I'm trying to get. So rafts, I would say, are kind of a last resort, but know that you can use them, and they are effective. Now, something I've alluded to both earlier in this lesson and in other lessons and units is picking a good build plate. Now, having a solid print bed, a high quality print bed, is going to make a big difference on your prints. But if you're a beginner, most likely changing some of the other things are going to have an impact on how well your first layer does as well. So I'll leave a link for the one that I have here down in the description, as well as some other ones that have worked well for others. The reason that I have the coarse side as well as the smooth side on this build plate, besides the fact that, depending on how you want the final print to look, sometimes having the coarse looks super cool, and sometimes having the smooth looks super cool. The main reason is because if I have smaller and more detailed prints, let's say it's something for a mechanical project that I'm working on, I will usually use the smooth side because it'll give me a result that is more consistent with the piece that I designed. However, if I'm printing something bigger, like let's say I'm printing a piece for a cosplay, if it's bigger and more likely to wiggle, and I'm not as concerned about how smooth that particular face is, then I will probably use the coarse side, because in my experience, having a coarse build plate, a coarse surface for the printer to move on, has improved adhesion. It doesn't necessarily increase it so much so that it's hard to remove, but it does make it stick better, because when you have all of these little nooks and crannies that the filament can go into, it just increases the surface area essentially. So the printer can, get more attached. One of the other things I really love about this print bed is it's fully metal. A lot of other surfaces use some sort of composite material or really just a plastic. And in that case, it's harder to clean, it's easier for things to get stuck to, and it also gets damaged easier. With this metal one, I can print pretty much whatever I want on it without worrying about it getting damaged or having trouble cleaning it, because it's just, I can throw anything at it. But again, I'll leave a link to the ones that I think are probably a good choice down below in case you do want to check them out. Now, here are some problems that you might run into when you're dealing with the first layer. Number one is warping. Warping is basically where the print starts fully on the build plate and then something happens and it starts to sort of peel up on the side. A lot of times it happens in corners, but sometimes it can spread like crazy. I've had prints just warp entirely off of the build plate before. Like big prints like this big, it'll start slow and it'll be like, it's fine, it's just a little bit, it's like this big. And by the end, I've just got this heaping mess on the floor of just mess. Warping can happen for a number of reasons. It can happen because, your bed is not leveled properly. It can happen because your temperatures are off. Like, let's say your bed is too hot and the filament can't cool down. But it can also happen even if all of your settings are great, your printer is perfectly calibrated, just depending on your model. If your model has a part where it's just very, very thin, like a millimeter, sometimes even less than that, like the fin of a rocket. If you're printing the fin of a rocket, it might, start to warp in the corner. And to solve that, I would just use a brim. That's, I'd say, the easiest place to go from there. A lot of times the warping only happens in certain areas. And if that happens, you can actually go into your 3D modeling software and just manually place in a brim. I'm going to show you how to do that in a later lesson, but it's good to know that you can do it. Another thing that you might deal with is elephant's foot. Elephant's foot is what you see at the bottom of a print sometimes, where it starts flat, and let's say you're printing a perfect cube, but at the very bottom, it just bends outward slightly. Like it looks like it's just supposed to curve down directly into the build plate. And it's not supposed to do that. It's not. What that's called is elephant's foot. So that can occur, again, for a number of reasons. Reason one is that your bed is not perfectly level, meaning that, it might be a little bit higher in some areas, but mainly the reason that, that throws it off is because the printer, the nozzle, is too close to the build plate. They're too close, and the filament has nowhere to go but out. So it presses down, and the filament just builds up, and it makes this sort of mound, and that's what causes it. So again, go back. You can adjust the Z offset or just manually do it on your printer. That's what I did for the first 3 years, and it worked great. Another thing you can do to try to combat this is to lower your extrusion rate, also known as your flow rate. Your extrusion rate, you can change a lot of times just straight on your 3D printer. You can also change it in software if you know that it's going to happen. But if you're dealing with it in the moment, you can just go in here and turn down your flow rate. This is just going to extrude less plastic, and that's going to mean less of the buildup. That can pose some other issues though, so just be warned. If you've tried some of these other things, or you realized, I don't really need it to be that precise, other things you can do are use what's called a deburring tool, which is, you can also use an X-Acto knife, but it's safer and more effective if you use a deburring tool. What the deburring tool does is it's just this little tiny hook, and you drag that hook along the side of the object, and it cuts off that elephant's foot. It can also cut off, the ends of brims if you have a brim on your print, or just add a very, very small indentation on the side of it. Again, I'll link it down below. You can get them super cheap, and it'll help you a lot. I use mine all the time. Sort of similar to adding the brims in your 3D software, another thing that you can do is you can add a very, very small slant, does not need to be big at all, to the bottom of your prints. And that, it doesn't prevent the elephant's foot, but it counteracts it. Honestly, it looks way better to have a slant in the bottom of your print. It's actually a design technique that a lot of people use even when there is no issue, no threat like elephant's foot, and it'll still look better. It'll look better than it would have beforehand. So don't feel like this is hurting your print, because it's not. Now, if you've realized that your biggest issue is leveling the bed, and your printer doesn't come with an auto bed leveling system, you can actually buy one and install it. One of these is called a BL Touch. You can get it for not that much money, and you just install it straight to your printer, plugs in, and yeah, it just goes through, moves your printer down, senses when it clicks it, goes to the next one, and it works just like any other one. There is a little bit more setup involved, but let me know if you want to see a tutorial on that, and I'll make one. Anyways, guys, that is all of the content for this video. But one thing I want to leave you with is just follow the principle of continuous improvement. Try something, tweak it a little bit, see what happens, record your results. The great thing about being in this community is you can share your results with other people, and we can all learn way faster than any one of us could on our own. So if I make a mistake and I show other people what my mistake was, whether or not I solved it, other people might comment and be like, hey, did you try this? And I'll be like, oh no, I didn't try that. I'll implement it. I can also be like, here's something I struggled with, and here's how I fixed it. And then we post it to the community, and everyone else can learn from that. So, I would really encourage you, both for you and for everybody else, if you're willing to do somebody else that you don't know, some total stranger on the internet, a solid, if you're willing to do yourself a solid, then share your progress. Anyways, thank you all so much for watching. You guys totally crushed it today. If you made it to the end of the lesson, you are a real one. Just shows how dedicated you are to doing this. So, good job. I'm Caleb, and I'll see you in the next lesson.